Hi everyone. So in this video, we'll explore how to build retrieval augmented generation application using LangChain. RAG architecture basically are a type of language like language model architecture basically. So they are not language model, but they are a separate architecture which make use of language model, and they incorporate relevant information from external sources like documents or web links or internet search, and they help us generate more informed and context aware responses. So now LangChain here it is a powerful Python library. It simplifies the process of building the large language models, applications using large language models like GPT-3, BERT, or Cohere, and others. And it provides a modular and extensible framework for building these applications, which can leverage the power of LLMs for different kind of tasks, including question and answering, text generation, and others. Cohere is an AI company, and it provides very strong, very powerful AI models. It is basically used for re-ranking purposes, but it also has LLM models which can be used for question answering and other related tasks. So in today's model, we are using command R model from Cohere, which is actually for question answering task. Okay. So we'll start with importing some of the important libraries that we are going to use in this video. So we'll import these libraries. Okay. Now once we have imported the libraries, uh, like, we have imported all the important libraries that we need. These libraries come from LangChain basically, so most of the libraries are, as you can see, are from LangChain. It includes Chroma library, which is a vector store. Then we have document loaders. Here we have document loaders, and we have text splitters to split our text, and we have embedding models as well to create the embedding. So we are using Hugging Face embedding model. Okay, and then because we are using Cohere model, so we have to set the Cohere API key in our environment. So we'll set this environment. So like API key is a secret key, so you should keep it a secret. It should not be shared with others, and it should not be shown in a public platform. So I'm also not going to share the this key with you. So give me some time, and I'll load this API key, and then we'll continue. I have set up the Cohere API key using the getPass module for secure input. Okay. Now we are going to create the LLM instance. So we have we are using ChatCohere API, and we'll initiate this API. We'll call this API, and we'll use the command R model from ChatCohere, like Cohere. So once it is initiated, now we have created the instance of Cohere language model using the ChatCohere class, and we have given the command R model. We have specified the command R model which we will be using in our RAG application. Okay. Next, we have to load the documents. So we'll load these documents. Okay. So we are using the PyPDF loader to load a PDF document, and we are using a URL here, but you can also use the path from your local storage as well. So this is an example of a research paper from arXiv, and you can load any document of your requirement. So you can use other document from any other link, or you can pick the document from your local storage. Next, we are going to create the splits. So we have to split the loaded document into smaller chunks, and we are using the recursive character text splitter for this purpose, and it ensures efficient processing and retrieval of the documents. So this is the default chunk size, standard chunk size that we are using 1000, and we keep the chunk overlap of 200 for efficient retrieval. Okay. Then we have to set up the embedding model. So we have set up the embedding model using the Hugging Face embeddings. Okay, this is a class from LangChain itself. So embeddings basically are the numerical representations of text, and they are able to capture semantic meaning, and we require this for efficient retrieval and comparison with the user queries. Okay. Now we have to keep these embeddings in a vector store, uh, from where we can get them later and compare them with user query. So we are using Chroma here. Okay. Now Chroma is a powerful vector storage solution, and this vector storage is now initialized, and the document splits that we have created using the splitter, uh, like their embeddings are created, and these embeddings are now saved in this vector store. Now we have to set up the retriever, which will retrieve and the related prompt. So we have set up the retriever and the prompt. Okay. So we have we have set up the retriever for the vector store. So it will be used to retrieve relevant information from the document. We have also loaded a predefined RAG prompt from LangChain Hub, which will be used to format the query, and it will be used to retrieve information from the language model. Now we have this helper function as well. So this helper function, it defines the format of the output retrieved documents, and it provides them in a readable string format to the language model. Now here we are establishing the RAG chain. Okay. So we have established the RAG chain. It combines the retriever, prompt, language model, and output parser in a sequence. The runnable pass-through is used to pass the user's question to prompt unchanged. Now we can query the RAG chain. Now it is ready. So we can invoke the RAG chain and we can get answers to our queries. So we'll first seek the answer for some simple question. So this is I've asked here what is the title of the paper that we are reading. So it has retrieved the title. We have asked it to summarize the paper in 10 sentences, and here is the result. So this is the paper, and it has previous work. So these are the relevant chunks. So we have asked for 10 sentences, so it has picked up the 10 relevant sentences from the document, and it has given us the surprise summary of that document. Now let's see if it can fetch the advantages. So it has given the advantage, like layout parser has many advantages, including ability to create large scale and lightweight document digitization pipeline with ease. It also supports training customized layout models and community sharing of those models. It makes it a versatile tool with numerous potential applications. So here is the paper. So we can see that yeah, actually it is about a layout parser, and the advantages, it must have gone through these this document, and we can see that it is picking up the advantages correctly from this document. So let's see if it can give us some more details about this paper. So here the information that it has received, it is not actually correct. So it might have been taking the comparing the relevant chunk only, and then it is giving the length of that chunk, not the document actually. So not all the queries are going to be answered correctly. As we can see, there will be some mistakes in this as well. So you have to use this tool, this implementation with precaution, and you have to take care that the output that you are getting is correct. And there are many other methods with which you can reduce these wrong methods, so which are not covered in this video. So like you can ask different kind of queries which are related to the paper itself. So you know that you are creating a document chat application, and you have given it a PDF, and now you want to retrieve information about that PDF. So you can ask related information, related question. If you ask some other question which is not related to the question, so suppose I ask it what is the purpose of life. So clearly the question is not related to this paper, but let's see what it is answering. So it clearly says that I'm sorry, I couldn't find the answer to this based on the context provided. So however, based on larger context of the text, which appears to be a document about toolkit for document image analysis. So now it is saying that like the purpose of life is not relevant to this document, but if we put this paper into that context, the purpose of life can be interpreted as the purpose of life or existence of this toolkit which is discussed in this paper. And in this case, in which case the purpose could be interpreted as aiding and improving the process of digitization. So somehow it has tried to put that into context related to this paper, but obviously the question is not related to this paper. So it has tried to somehow fit into this context. Now, this is all for creating a document chat application using LangChain. I hope you find this video helpful, and if you like if you have liked it, if you want more such content, you can subscribe to my channel, and you can like and subscribe, and share it. And one more thing. So I'll share the relevant links. Like there are some links which I want you to go through. So these links are related to LangChain. You can go through LangChain documentation, Cohere documentation, and the paper which is about retrieval augmented generation. So all these links will be provided uh, in the description of the video, and I'll also share the code. I'll put the code on GitHub, so you can find this Python notebook on GitHub, and you can download and you can try at your end using your own Cohere API key. So I'll share the link to the code as well, and you can download and try on your own. Okay. Thank you.